Welcome students. In this video, we will be doing the implementation of reversing a linked list. Method 1. Method 1 is reversing the elements. Still we have not, we have not into the second method, reversing links. First of all, we will finish the implementation of reversing a linked list using first method, reversing element. Okay. Then we will look into the next method. Fine. So now we'll just, I think already we have we have the piece of code, okay, for reversing elements. Okay, so now we will just start with the implementation part. So before starting, I actually wanted the create linked list method. Okay, we want the create linked list method. So let us take a copy of a create linked list method. Okay, let me take a copy of it and let me have it here. Let me remove these two methods for now. Okay, so for this create method, we actually wanted a structure, struct node, and which is going to have integer data, and it will be having a self-referencing pointer struct node star next. Struct node star next. Okay, the structure is okay, fine, ready. Now the create method, I think all these things I can take it off. Okay, so what we have to do is inside the create method, we should also find the length of the linked list, which is very important for method 1 of reversing linked list. Before that, let me include a library hash include stdlib.h, because inside this library only we have malloc function. Okay, fine. Now when this process is taking place, we also have to find the count. Okay, so what we will do is after receiving and inserting first element, let me declare a variable called as len and initialize it to 1, because one element is already inserted. When you enter into this while loop, every time increment your len variable by 1, because every time when you when you enter inside, you will create a node and you will insert the element. Okay, so you increment your len. Okay, so now automatically len will be having the length of the linked list. Start with 1, increment whenever you enter into this while loop, automatically len will be having the length of the linked list. Okay, fine. Now let me write void, and this is going to be reverse element, right? This is reverse element method, right? So we will write reverse element method function. It is going to take argument called as first. So it is struct node star first, a pointer called as first, comma, and this pointer first and this pointer first is totally different. Okay, so now then the second argument is going to be the length of the linked list, so int len. Okay, fine. Now inside the block of this function, reverse element function, what's the first thing we should know? We should be taking an array of length len. So let us take a integer array arr of length len. Now also we will take one more variable called as I. Let it be the I is going to point to the index of array. I is by default starting with 0th index of array. Now what I need to do, I need to copy all the elements of linked list to the array. So what I need to do is, I need to first of all take temp of data. And I need to assign it to arr of I. So I need to assign it to arr of I. Ith index should take temp of data. It should take temp of data. Okay, fine. So after taking temp of data and storing it in ith index, the next process will be incrementing your I variable and moving your temp pointer from present node to next node, which is temp equal to temp of next. Just temp equal to temp of next. Now the next thing is, okay, so the next thing what we need to do, nothing, that's it. So take temp of data, assign it to, okay, it's not, sorry, temp, I think we have not still taken temp, right? So what we will do is we will take temp separately. The reason why we want two pointer called as first and temp is because once we do a complete iteration, again we will start the iteration from the first node. So address of the first node is very important, so let it be with the pointer first. Let us not affect it, but we will create our own pointer temp and we will have the address of the first node there also. Now we will use temp for the, we will be using temp for the traversal. But this thing only we are copying one element, okay, we are just copying zero, we are copying the first element to 0th index and we are moving to second node. Only one time we are doing it. But how many times this has to take place? This should take place until we reach the last element. So while temp is not equal to null, it means that still we have not reached the last element. So while temp not equal to null, then we should be doing this traversal and also the copying process. We should be doing the copying process, right? After doing this copying process, struct node star temp is equal to first. After doing all this process, coming out of the while loop, what is the next process that I need to do? Temp is now equal to null. After you come out of while loop, temp will be equal to null. Take that temp again back to the first pointer. So temp is equal to first. Again it is taken to the first pointer. Then I will be there out of the array, which I need to decrement by 1 to take it again to the last index of the array. So I is decremented by 1 position. Now what we need to do? We need to copy back the elements from array, but in the reverse order we need to do the copying process. So now it is going to be vice versa. We took temp of data, copied to ARR but now ARR is going to be copied to temp of data again. So now temp of data will be equal to ARR and after copying it, temp should be moving to the next node. So temp is equal to temp of next, and I should not be incremented, I should be decremented. We are doing the copying process in the backward direction, so I'm decrementing our I variable. Until when this should happen? Again, this is to the end of the linked list, this should happen. So again the same condition, this 3 lines should be within a while loop having condition temp not equal to null. Okay, fine. So inside while temp not equal to function, we have this 3 lines. Okay, fine. So until temp becomes null, this reverse copying will take place. So after reverse copying, now if you look at the look at the linked list, it will be completely reversed, but only elements are reversed. So this is reverse element method 1 concept. Copy all the elements of linked list to array, then again copy back from array to linked list, but in the reverse order. That's it, simple. Okay, now after calling this create function, after finishing it, now let us call the function reverse element. Okay, let us call reverse element by passing the address of first node as a first argument and the value of length of the linked list as the next argument. So after calling it, now we have to call display function to display the linked list. So we already have the display function. So we will take the help of that the display function already, which we have we have coded already. So we'll take it and we will paste it here. I think all this time complexity things you don't want, I think so. Yeah, fine. So we'll take this off. Okay, so let me say, so now after doing the reverse element call, I will now call the function or display, the recursive display procedure, and I will pass the address of the first node and we will check whether elements have been reversed or not. Okay, we'll put a try. So go to terminal. Okay, fine. So now we have to go for cd this linked list. Okay, gcc hyphen o hello, and the name of the file is reverse. Okay, sorry, it's remove. Okay, it is going to be reverse elements. Is there any error? No error. Go for execution. I think we have not called the function create. Yes, we haven't called the function create here, so create function. Okay, fine. So now let us again go for compilation and again go for it. Now just let us check. We will enter elements and let us check whether it is printed again in the reverse order. So 12, 23, 34, 45, 56, 67, 78, 89, and last -1 I will enter. Just check. You entered 12, 23 on order, but it is getting printed 89, 78, 67, 56, 45, 34, 23, 12. So linked list is completely reversed with the help of method 1. But still we don't say that this is an efficient method. Reversing the link is what the efficient process is. That's the next thing that we are about to see, right? So now in this video we implemented method 1 of reversing a linked list, that is reverse elements. Procedure is copy all the elements of the linked list to a array, then again reverse copy all the elements from the array in the reverse order to again back to the linked list. So everything is reverse. So implementation is also perfectly working. Okay, fine. Hope to meet you in the next video. Thank you.